Okay, we're going to continue our discussion of section 16.1. This will be part 2, continuation of properties of solutions. We're going to be talking about what affects how something can be dissolved, and in our discussion here we're going to be looking at temperature, and that temperature affects how all things dissolve, solid, liquid, and gas, in a solvent, but both temperature and pressure affect gaseous solvents and solutes. So when we're trying to dissolve a gas, we have to take into account both the temperature and the pressure. When dissolving a solid substance into a solvent, for the most part, the solubility increases as temperature increases. So looking at this graph here of temperature versus solubility, I can see that for most of the things here that the solubility is going up and increasing. As temperature increases, solubility increases. But there are a few things where we see the solubility decreasing. This table shows the solubilities of various substances in water at different temperatures, at 0 degrees Celsius, at 20 degrees Celsius, 50, and 100 degrees. So the first grouping of substances here are all solids, and we can see that as a general rule we go from 35 to 36 to 37 to 39 for sodium chloride, increase with temperature. We can see that some increase a more significant amount. For example, silver nitrate goes from 122 grams to 222 all the way up to 733 grams at 100 degrees Celsius. So we get a significant difference in how much solubility changes. Down here at the bottom, these are gases, and if you notice that gases, their solubility is actually going in a downward trend, that showing that less would dissolve as we increase the temperature. This table shows the maximum amount that can be held at a certain given temperature. If you made a solution with these amounts, we would call it a saturated solution. There is such a thing as a supersaturated solution that contains more solute than it could theoretically hold at a given temperature. So looking at the table on the previous page, we would be able to hold more solute than was listed in that table. These kinds of solutions are very unstable, and the excess solute can be crystallized out if we do something to mess up or disturb that stability. We could add a very small crystal, sometimes called a seed crystal, to the solute, and the excess would crystallize out. Here's an example of a supersaturated solution. So this is a supersaturated solution, and a very small seed crystal is being added, and as it's added, the excess begins to very rapidly crystallize out after that has been added. If you ever had gotten one of those crystal growing kits as a kid for a Christmas present, those begin with supersaturated solutions, and the crystals begin crystallizing out, and that's from a supersaturated solution. For gases, as we said earlier, the solubility of gases is opposite that of solids. So for most gases, the solubility is greater in cold water than in hot water. And also pressure changes will influence the solubility of gas, but does not have any effect on solubility of solids and liquids. So gas solubility can increase as the pressure above the gas above the solution increases. So as I increase the pressure of the gas, more and more of the gas particles will dissolve in the solution. So here's a good example of carbonated beverages. There's a good example of gas being dissolved in a liquid. So we have large amounts of carbon dioxide dissolved in the water or the solution. And the dissolved carbon dioxide is what gives it the fizz. The soft drinks are bottled under a high pressure of carbon dioxide gas. So here above the solution we have a high pressure of carbon dioxide gas, and that high pressure forces more of the carbon dioxide into the solution, which is why when you open it, you see we've lowered this pressure that's above the solution, and so the gas is escaping out of the container. So by lowering the pressure, we're allowing that carbon dioxide to escape and become undissolved from the solution. We do have a relationship between pressure and solubility, and it is known as Henry's law. And Henry's law says that the solubility of a gas is directly proportional to the pressure of the gas above the liquid. So what that means is, as the pressure of the gas increases, the solubility of the gas increases. And as I lower the pressure, the solubility of the gas decreases or lowers as well. So it's a direct relationship. We can write this relationship in the form of an equation, much like our other gas laws that we used. So the S is the solubility and P is the pressure. So looking at S1 over P1 equals S2 over P2, looking at the solubility and pressure changes.